This is going to be section 2.1 of my PreAlebra series, and we're going to talk about solving equations using the addition property. And we're going to talk about a number of basic things in this video, a lot of fundamentals. So what we're going to start off with is, what does it even mean, because we're talking about solving equations, what does it mean to be a solution of an equation? We'll talk about that. We'll pick out equations versus expressions. We'll learn how to pick out those equations. We'll use what's known as the addition property to solve an equation, and then we'll also work some examples that involve the distributive property. And this is going to be just kind of an introduction. So certainly this isn't going to be everything one needs to know about solving equations. It will be one very small class of functions, but very important. They come up all the time, known as linear functions. So the following are all examples of equations, and I just kind of picked out 3 at random. We have 2 plus 5 equals 7, x plus 5 equals 7, and a equals 1/2 b times h, or area equals 1/2 base times the height. Maybe you remember that last one. That's the area of a triangle. And as I have over here, simply notice the equal sign, right? In each of these, we have an equal sign, and so we have an equation. That's all you're looking for. We have 2 expressions, and those expressions are set equal. Those 2 expressions are equal to each other. So, as it says here, an equation is a mathematical statement that 2 expressions are equal. I always thought about that, equal sign as sort of a dividing, kind of like a little fence. You have one side, you have the other, but whatever's on one side is equal to whatever's on the other side. So let's start with this equation, x plus 5 equals 7. So ultimately, what we want to do is, we're trying to figure out what value of x, right? I want to replace x with some number. I want to do all the arithmetic, and I want whatever happens on the left side to be equal to whatever happens on the right side. Well, notice, for example, here, there's not a lot of arithmetic to do on the right side, but there could be. This could be a more complicated equation. You could have 2x plus 4 minus 1/3 x equals 8x plus 7. So ultimately, again, we're trying to figure out what value we can replace. Everywhere we see an x, we want to replace all of those x's with some specific number and have the left side equal the right side. That's what we're looking for here when we talk about finding a solution to an equation. So for example, let's just take these values of x equals 0, x equals 1, x equals 2, and substitute them into that equation. And I think we can go through these relatively quickly. So if I substitute in x equals 0, well, I would have 0 plus 5 equals 7. That gives me 5 equals 7, which is clearly not true. So what that means is that x equals 0 is not a solution to that equation. And likewise, we could check x equals 1. So if I check x equals 1, what's that going to give me? So again, I'm just plugging it into this equation. So I would have 1 plus 5 equals 7, or 6 equals 7, which again, those aren't equal. So x equals 1 is not a solution. But of course, hey, notice when we plug in the last one, x equals 2, I would have 2 plus 5 equals 7. That is 7 on both sides. That's equal. So x equals 2 is a solution. That is a solution to that given equation that we started with. And what we want to do is we want to be able to, we want to be given an equation and be able to find the solutions. We don't want to just plug in numbers and check it like we did here. There's no guarantee you'll ever even find a solution. Or there could be many solutions. So that's something we have to worry about depending on the type of equation. So we need a process to actually help us find those solutions. So let's look at one more example again about what it means to be a solution. So is x equals 3 a solution to either equation? So again, if I look at my first equation here, everywhere there's an x, I see 2 x's floating around. I'm going to replace each of those with the number 3, do the arithmetic, and see if I get the same thing on the left side as I do on the right side. So I've replaced my x's with 3, and I'm even going to put a little question mark above my equal sign because that's what I'm asking myself. Are those equal? Well, 2 times 3, that's going to be 6. 6 plus 4 on the left is going to be 10. On the right, we have 3 times 3, which is 9. And then 9 plus 5 is going to be 14. Well, those are certainly not equal, so x equals 3 is not a solution for the first one. And of course, be careful when you do your arithmetic and your order of operations in these. Do be careful about that. And if we check the second one, well, again, I'm going to do the same thing. I've got a couple of x's. I'm just going to replace both of those with 3. You could have lots of x's. That's no problem. Well, on the left, 4 times 3 is 12. Minus 6 is going to give me 6. On the right, 5 times 3 is 15. Minus 9 is also going to be 6. Hey, those are equal. We would say x equals 3 is a solution. Okay, so that's what it means to be a solution. And a quick little question here. Can an equation have more than one solution? And I think I alluded to this earlier. So let's look at this equation, x squared minus 1 equals 0. Can you think of a solution? Can you think of some value that you can square and then subtract 1 and get 0 out at the end? That's what this all says to do. It says take the number, square it, then subtract 1, and you want that to equal 0 at the end of the day. Well, notice if I plug in x equals 1, I would have 1 squared minus 1. Well, 1 squared on the left, that's going to be just 1. 1 minus 1 is 0. Hey, 0 equals 0. So that means x equals 1 is a solution. I found a solution. Now the question is, are there any others? Well, can you think of any number that you could square, subtract 1, and get 0? 0 wouldn't work, but what if we use negative 1? Right, because if I replace x with negative 1, negative 1 squared minus 1, well, negative 1 times negative 1, that's negative 1 squared, that's going to be positive 1. Positive 1 minus 1 on the left will be 0. And hey, those are equal, so x equals negative 1 is also a solution. So we have 2 solutions. And it's going to turn out, some of these equations we've been looking at, there's a way to classify those. This second little equation also falls into a different class. The first one are what are known as linear equations. We're going to talk about those more in just a second. The second one is what's known as a quadratic equation. So again, we're getting a little ahead of ourselves, but that's sort of the direction we're going. You're going to want to classify these different types of equations and be able to find techniques to find solutions to those equations. Okay, so again, as I said, we will focus on linear equations. So a linear equation is an equation in one variable that can be written in the form ax plus b equals 0, where a is non-negative. A does not equal 0. And all that means is, since a is not 0, we're going to have some non-zero number multiplied by x. We're going to have some term involving x in our equation. That's what we want. Okay, and one thing that we'll want to do, one thing you'll want to be able to do is just to look at an equation, and it may be all jumbled up. It may not be in this nice little form. You want to be able to still look at it, though, and say, aha, that's linear. I know how to solve that. Or maybe it's not linear, but I know how to solve the other ones as well. Maybe I could say, aha, it's not linear, but it's quadratic, and I've got techniques to solve those too, or at least we will learn them sooner than later. Okay, so let's go back. Are these linear or not? And what I'm looking for is, I'm looking for x's to the first power multiplied by some number. There can be lots of terms involving x to the first power, and then I'm just adding and subtracting some number. And the right side doesn't have to be equal to 0. We just want to be able to take our equation and put it in that form. So what do I mean here? So for this first one, I see there's a term involving x to the first power. That's no problem. So far, so good. I can just be adding and subtracting numbers. No problem there. And I've got my 7 over here. No problem. So yes, this would be linear. And I think you'll start seeing here in a second when we find ones that are not linear. And again, if you want to put it into this form, Notice it says we want our term involving x first. Well, I've got that here. I've got x by itself. And then what I could do is, now it says we want to make the right side equal to 0. We want to make the right side equal to 0. So there's a way we can do that. There's a way that we can put this in this form, ax plus b equals 0. And that's going to, again, be using this addition property that we'll talk about in just a second here. Okay, so the first one is linear. The second one, okay, again, there's an x to the first power multiplied by some number, fine. I'm adding or subtracting some number, no problem. On the right side, I've got some number multiplied by x. That's okay. I could combine the 4x and the 5x. There's a way to do that. And then I'm just subtracting this number 9. No problem. So this one, in fact, would be, again, that would represent a linear equation. Now, things that you don't want, we don't want x to any power other than positive 1. So this, in part C, I have x squared minus 1. This exponent of 2, that's messing things up. This is not going to be a linear equation. Again, it is what's called quadratic, a quadratic equation. Well, let's look at D. We have this 1 over x plus 5 equals 7. That looks pretty similar to part A, right? The only thing that's different, instead of x, we've got 1 over x. Well, is that linear? Is it not linear? And the idea is no, because notice when we look at this form, right, the x is not in the denominator of a fraction. It's just hanging out there. And I could rewrite this equation. Notice I could write 1 over x. I could use properties of exponents and write that as x to the negative first, and then plus 5 equals 7. And again, notice I don't have this x to the first power. That's what I want. I want an x to the first power. We don't write it, but it's understood it's a degree of 1. But now I've got negative 1. So that's messing things up. So no, this is not linear. And likewise, in part E, I have this x squared floating around. That's enough to say, nope, that's not going to be linear. If that term wasn't there, well, then we would just have our x plus 5 equals 7, I guess. Then it would be linear, but it's one we've already seen. Okay, so no, that is not going to be linear. And again, it could, I'm kind of just trying to make a few different examples. This exponent, it could be a 1/2, 2x to the 1/2. That, again, would be not linear because it's just not x to the first power only. That's what you're looking for. So just be careful about those. So those are the first couple we had, yes, those are linear. The last few are not linear. So again, our goal here is to manipulate, and by manipulate, I mean we're going to use algebra. That's to me, when people say use algebra, what does that mean? Those are the tools that we're allowed to use. Those are the ways that we can manipulate these equations. We're going to manipulate these equations to find the solution is what we're going to do. And as I said, down the road, eventually you're going to have lots of different types of equations, and you're going to have lots of different techniques. And it's taken literally hundreds and thousands of years to come up with these techniques. So it is quite fascinating historically, because we didn't just always have this information and these tools. Okay. So here we go. The name, it's like when they say the name of a movie, the title of the movie in the movie. It's like, ooh, okay. So here's the title of the section in the section. This is where we're actually going to talk about this addition property. And you'll do this and you'll just won't even think, hey, I'm using the addition property of equality. You'll just use it. So what does this addition property of equality say? It says, well, if A equals B, if you have two things that are equal, well, if I add some amount C to the left side, and I add that same amount C to the right side, well, those two expressions on the left and right are still going to be equal. And that makes sense, right? If two people have, the same amount of money, Alice and Bob have the same amount of money, if you both give them, an extra $10, well, they still have, an equal amount of money is the idea. It's still equal. So let's solve this equation, x plus 5 equals 7. And to me, the goal on these is I want to get the x all by itself. I want to do a bunch of work and get one x all by itself to where it just equals some number. That's going to be my goal. Sometimes I can do it really quickly. Sometimes it's going to take me a few more steps. Well, let's start again with x plus 5 equals 7. Well, I want to be left with just x. Again, I want to be left with just that term. Well, I'm adding 5 to the to that value of x. I'm adding 5. Well, what I could do, if I want to get rid of that, well, what could I do? Well, if I've got x plus 5, let's just subtract 5. Well, and this is the idea. So I've taken what was on the left side, and I've either added or subtracted something, and I'm going to take whatever was on the right side, and I'm going to add or subtract that same amount. So notice all I've done is I've just subtracted 5 from both sides. Well, on the left side, x plus 5 minus 5, that's just going to leave me with x. On the right side, 7 minus 5, that's going to be 2. And again, we said that was our solution. That's what we plugged in to make the left side equal the right side. And you may say, hey, of course it's 2. This is super simple. I don't need to do all these steps. Of course, it's going to get complicated very soon to where you can't just look at it and say what the number is. You'll really need to have, again, these algebraic techniques. So we are, again, I was going to say walking before we run, but probably even crawling here right now. Okay, so again, just to re-emphasize what I said, in general, and again, this is for linear equations, I want to stress that, I like to get all terms involving x, or, maybe you have just the variable y or the variable z, just whatever the variable is, to one side and all the constants to the other side. And I like to try to combine those. So a second ago, I kind of put my thing out to the side. I subtracted 5. Usually, at least for myself, a lot of times when you see people do these, they'll kind of do it in like a column. So that's what I'm going to do here. So, and this is what we're trying to do. We're trying to find the solution. So I've got 5x plus 18 equals 4x plus 22. I want to get x's all by itself on one side. Well, I see a 5x on the left side of my equation, and I see a 4x on the right side of my equation. Those are where my terms involving x are. I want one side to have no x's. And what I'm going to do in this case is I'm going to subtract 4x from both sides. So I'm subtracting 4x for both sides, and notice I'm already kind of lining up my like terms. So 5x minus 4x, that's just going to leave me with x on the left side, still plus 18. Well, 4x minus 4x is going to be 0x, and then we still have our plus 22 left over. And now we're back to like our other example, that we started off with. Here I was adding 5, so I subtracted 5. Well, now I'm adding 18 to the left side where my x is. What I'm going to do is I'm simply going to subtract 18 from both sides. And that's going to leave me with just x on the left side, because plus 18 minus 18 is 0. And then 22 minus 18 is going to be 4 on the right. And that's going to be my solution. And notice we could even go back and you could check it. Right? You could check it to make sure, because 5 times 4 plus 8, does that in fact equal what we get when we take 4 times 4 plus 22? Well, let's see. 5 times 4, does this do it? I left out, I was going to say something's wrong here. I should say 5 times 4 plus 18. I said plus 8. Okay. So I'm just replacing both of my x's with 4's there. So 5 times 4 is 20 plus 18. I'm going to get 38 on the left. And notice 4 times 4, that's 16 plus 22. That's also going to be 38. That's also going to be 38. So in fact, we do have the solution. And that's one way you can always check whether or not what you found, if you think, is my algebra correct? You can always go back and plug it into the very original equation, do the arithmetic, and see if it's correct or not. And I would always encourage people, especially when I tutored or taught, I would say, hey, if you're doing this stuff, if you have extra time before you run out of time on your quiz or test and you have a solution, do go and check it because you'll know immediately if it's right or wrong. And if it's wrong and you have time, hopefully you can fix it. Okay, so let's do a few more examples, and I'm going to go through these a little faster. So I've got 6x plus 3 equals 5x. And again, there's a lot of different ways you can do these, okay? There's not like one strict path you have to follow. So to start this one, I'm going to subtract 5x from both sides. And typically what I like to do is I like to subtract the smaller value from the larger value. So to me, 6x is going to be larger than 5x, assuming x is positive. I don't even really care about that part. What I'm doing is just looking at the coefficients on x. So I'm taking the smaller coefficient and subtracting that away from the larger coefficient. And the only reason I do that is it just keeps my terms involving x positive. So 6x minus 5x on the left, that's going to be positive x. Let me change my color. That's positive x plus 3. Notice on the right, 5x minus 5x, that's just 0. But what I could do is subtract 3 from both sides. I would be left with x on the left side, 0 minus 3 on the right. Well, 0 minus 3 is just negative 3. And again, that's going to be my solution. Now, the next one, 4x minus 3/5 equals 3x plus 1/10. So we've got some fractions, different ways to get rid of these. I'm just going to go ahead and start combining things. So again, I see a 4x and I see a 3x. Those are my x's. Well, 3 is smaller than 4, so I'm going to subtract 3x from both sides. And notice on the left side, that just leaves me with positive x minus 3/5. And on the right side, the 3x minus 3x cancel, but I still do have that positive 1/10 left over. And now, okay, I've got x minus 3/5. I'm just going to add 3/5 to both sides. So that's going to leave me with x on the left side, because the minus 3/5 plus 3/5, those cancel. And that's going to leave me with 1/10 plus 3/5. Well, we could get common denominators by taking that second fraction and multiplying top and bottom by 2. So my first fraction, that's still 1/10. If I get common denominators by multiplying top and bottom by 2, that's going to be 6/10. And let's see, so that's 1 plus 6, or 7/10. So again, it says that x equals 7/10, or I'll write it just here more compactly. X equals 7/10 is going to be the solution to our equation. And again, you could check it. Let's look at a couple more. This one just involves distributing. That's the only new thing. So typically, if you have these linear equations and you see some parentheses, get rid of the parentheses by distributing the coefficient. So I'm going to distribute anywhere I see parentheses. So 2 times 8x, that's going to give me 16x. We just take 2 times 8. Leave the x alone. 2 times positive 3 is positive 6. The right side, there's nothing to do because there's no parentheses. And now, okay, 15 is smaller than 16. So you may notice these are all kind of set up rather nicely. Maybe you haven't noticed, but we'll talk about this. So 16x minus 15x, that just leaves me with 1x. Plus 6 is still left over on the left. And on the right, the 15x minus 15x is 0. It still equals plus 1. And I could subtract 6 since I'm adding 6 on the left side. And 1 minus 6 will leave me with negative 5. And again, that will be my solution. All right, last but not least, same thing. We're going to distribute, but now I've got parentheses on both sides of my equation. That's fine. We'll just do a little extra work. So let's see, on the left, 5 times 5x, that's just going to give me 25x. 5 times positive 3, that's going to be positive 15. Now we'll distribute on the right. 3 times 8x is going to be 24x. 3 times negative 2 is negative 6 plus 4. I'm going to do one step and just combine my like terms on the right. So I've got negative 6 plus 4. That's going to leave me with negative 2. And as you get more comfortable with these, you can certainly start combining many steps at once. But we'll try to show a couple extra. Well, again, I see a 25x, I see a 24x. I'm going to subtract that smaller coefficient. So minus 24x from both sides. Well, 25 minus 24, 25x minus 24x is just x, plus 15 equals, okay, we're just left with a negative 2 only on the right. And then we'll subtract 15. So minus 15, minus 15. And then we have on the left just x, negative 2 minus 15. Since they're same sign, they're both negative, we could just pretend they're both positive. That would give me 17, but again, we keep that negative. So negative 2 minus 15 is going to be negative 17 as my solution. Now, you may have noticed again, every single time, we always ended up with an equation of the form. We ended up with 1x equals, just a number, right? Every time I simplified 25x minus 24x, hey, that's 1x. 16x minus 15x, that was 1x. 4x minus 3x, that was 1x. Okay, so all of these were set up in a very specific way. But what if we have an equation like this last one here? 4x plus 7 equals x minus 2. I could do the same thing. I could combine all my like terms. I'm going to try to put all my x's on one side. So I could subtract x from both sides. 4x minus x is 3x on the left. Just left with negative 2 on the right. And now, okay, I've got 3x plus 7. Well, let me subtract 7 from both sides. That's going to leave me with 3x equals, well, negative 2 minus 7. That's negative 9. So in all of our other examples, right, we were able to just reduce to x equals something, and then we were done. But what if we have this coefficient in front of x that's not just a positive one? Like in this case, we have a 3. Well, you can probably guess a solution here. I mean, you can think 3 times what number is equal to negative 9? Well, I think if I make that number equal to negative 3, so I think if x equals negative 3, that would be a solution. But from here, we want what we're going to do is we're going to discuss yet another algebraic technique when we get to this step. So the coming sections, we're going to talk about what do we do once we get to here. So I'll leave this video here for now. But once we get to these, you'll see it'll be just really one more step. It's not going to be anything. You're not going to be adding a lot more work once you get to this point. So, okay, all right. I hope this video makes some sense. Just talking about linear equations, what it means to be a solution, how to find those solutions. And again, picking out linear equations sometimes can be a little tricky, but once you do a couple, I think you'll be okay. And you'll solve a million linear equations in your mathematical career. So before long, you'll get pretty familiar with these, and you'll know this little recipe, and I think it'll be like second nature